Hi. Well, today I'm going to try and talk about the project, but I want to focus first on what our proposal should include. Our incentive mechanism, miner design, validator design, business logic, strategy. Making your video, I want to kind of go through some of this stuff here real quick. So when I started addressing the connecting to a decentralized network, was noticing that there's a lot of modification of my code, and I did not like because my code is pure and it has an intended purpose. So this whole event is like not intended yet. It's a couple steps early. So as I'm looking at this, trying to figure out a way to keep my code pure, the only thing I can come up with is my coin was going to be called Merit Coin, so I can come up with a Merit engine. It's a modular plugin that allows the software to, uh, 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 or the plugin will allow the adaptation of the software to connect to the network. So I want to modularize this connection so my software can get on the network. And so it's a lot of it's about emissions. Almost everything's already doing that anyway. But to start, I guess now that I know I'm going to have a Merit Engine module to connect all of this with the miner task, I guess we can kind of start out there. Miner is pretty much just computation. Um, are you up? What are your bonuses? Are you up the whole time? Is it a consistent performer? Limited impasses? The validator design is just going to have to kind of work in that with it. They're kind of resonators are going to be scoring coherence, applying the multipliers and doing the actual distributions of the emissions. Low quality events. You're going to discourage bad behavior by reducing yield from low quality events. Business logic. Well, each one of these that I'm bringing to the table, PhyLab, thermostasis, 5-wall, Brad. I'm not going to do the liquidations in this one. I have a whole TiTech liquidation pipeline that could also get loaded onto a decentralized network as another layer of marketing, but I'm not adding that in right now. It's just the infrastructure thermostasis, which is, gosh, I guess you could call it as like it's a thermal protector. It's an offloader. It's going to decorate functions or classes with a decorator as to whether or not it is a custom process, high compute process, some small one that can be offloaded. It's going to work directly with a dispatcher to ensure that high priority computational processes get sent through unaltered. Even if we have to pause batch processing, we'll be able to pause the whole batch process to allow something of heavier compute to slip through. Just make sure that you don't melt your silicon ultimately. But when we're offloading, we're looking at offloading resources across a decentralized network, it becomes a much more valuable tool. So that's the first one I wanted to probably focus on. That's the big monetary one, because everybody that can join the network is going to be able to get access to utilizing all the resources of their machine without having to worry about melting it. So even if you want to overclock it, thermostasis is going to wrap over top of it and make sure you don't melt, unless you do some stupid shit like overvolt. That's not my problem. Brad the Builder. Brad the Builder was a coding program that's designed to work with you. It has multiple memory lanes, so it can monitor what you have inside of your repo and see it all. We'll have a pre-commit lane where you're currently making your edits at, so it'll have access to a snapshot, also what it is currently. That way any other continued edits will be able to show up. It'll immediately start to have a picture of part of it when I had it set up, I think. Where's Brad? Brad the builder. I don't know. Maybe I didn't find it. Oh, that's on my phone. I'll have to take that back out. But it's a browser system right now. It's just going to show an accordion structure on one side, the types of files that you can select that it's going to recognize on the right-hand side, any kind of errors that it's finding, dead ends. It'll start color coding everything based on the error that it finds. That way you can see immediately into the file structure as to which folder has problems and what type of problem that it is based on the color of the accordion that is breaking down. And you can cycle through it, do some searching for specific calls or tags or functions, commit. This is going to scale up with tenants, so it's more than just a single dev type thing. It can scale out to like a team of 5. Everybody can have projects assigned to them from the same repo. The super admin can take a look at multiple versions, side by side them, see which ones are going to be best and commit the best one, or send them back down to fix before they get sent back up. So, you know, there's enterprise level tenant structure kind of already worked into this. It's not wired, but it's planned for. Hi-Fi itself is a zero epoch birth artificial intelligence. So I call this harmonic artificial intelligence with firewall resonance. The firewall resonance is made up of structures that I found while developing Brad, thermostasis, and the Tilium's Titech pipeline for our liquidation business. Within those 3, I found a way to birth AI. So not through standard top-down, but through bottom-up, through nurturing. We're going to use the medium as the information medium, source of truth, as the birthing medium. There's another element, firewall. That's the laboratory. Firewall is the that's Hi-Fi. Firewall is the AI. Lab is the detectors. That is what is going to mirror firewall as it grows. Start running over some of these images, I suppose. This is what I currently have up on Git. It's all private. You can't access it. You're not allowed. To start real fast, I guess, so there's 3 other protocols that I use right off the top along with the Arrayus reconciliation is WCW, which is War on Computational Waste, KISS, Keep It Simple Stupid, and WARM, which is waste as asset resource management. So those 3 sit above all development. Doesn't matter what we do. Those are the core 3 premises that we work from. The Holy Trinity, so to speak. Within that Holy Trinity, we find this. To explain this simply, this and this were all found by using this. Okay, so I'll let that sink in. But that's also, you know, it's a simplification process, essentially, to where we can transmute down, purify, applying impasse protocols, allowing thermostasis to handle the strain. Once it reaches purification, then we retransmute back up. We start to create something. So we start with a problem, we reduce it down to what is actually the cause, and then from the cause, turn it back up into where we want to be, into the solution. And that's essentially impasse protocol. You know, so it's pretty simple. It just looks weird mathematically expressed. Where are we at? I'm gonna have to trim this a little bit. So we can show the map. That's our map. This is how I'm building hi-fi. We're going off of what everybody knows. This is just funny. But this is here's proof, right? So here's proof of thermostasis and in-pass protocol working. So this is a 120 gig Llama model. This is running on, as you can see, 64 gigs of RAM, 32 threads, got 2 gigs of swap in there, and a 4060. 4060. So we got 12 gigs on the video RAM supporting this. And we're pushing, you can see in here, in the Pantheon paradigm, excuse me. That's exactly what it's doing. It's talking back and forth exactly how I want it to do. That's the in-pass protocol working. This is when I started doing, shortly after this, I started doing the archetype imprinting. This was figuring out that I could really push my system in thermostasis is going to stabilize it and make sure it doesn't break. Now I know this isn't good. This is horrible. You never want to push it like this over a period of time, but thermostasis works and pass protocol works. I would never do that because I don't want to melt my system, but you can. But anyway, there's that. I got a little bit. That way you can see it running and actually, there we go. It's not horrible. What is that, 6 to 8 tokens a second? Somewhere around there. Anyway. This was Tillian. This is my original concept for just having the AI image classify tagger work in. So this is layer 6 of 7 inside of the enrichment pipeline. So I'm a Phi Lab. This was the start. My heat map isn't working, but this is the start. So the very top layer is an archetype weight overlay. These weights are adjusted by a profile, and this one is my profile, INTJATA, I think. Was weighed into this one. Either way, it's changed a little bit more since this. But this is showing whether or not to take a step, merge a branch, don't merge a branch. The medium was incredibly macro here, so there was only a couple of steps that it actually recorded, or micro, it's pretty micro. So it doesn't really show a lot of steps that were recorded, but these are the particular types of young archetypal overlays, and I just played with them as far as, you know, old god names based on what they would actually do. Like Loki is the doubt injection. Daedalus is more the defendery. And they'll have, you know, certain types of emotional overlays in there as well. But that was the old Phi Lab. It has changed and shifted a little bit. You can see some of the settings. I've added more since then. Being able to, these are 2 different dashboards that I have working right now. One's the config dashboard and one is the watching the steps. So I can take whatever run ID that we have and load based on however many steps that we had working, so we can start to see what was going on. This one immediately created structure at start and held it the entire time. So this was proof. Now it just needs to expand the medium and see what it's actually going to do. I have a feeling that this is going to be as fast as lightning. Is going to be fast. What else we got? Other Phi Lab viewers at the same one. It's the same one. What about this one? Yeah, it's a little bit different. Heat map. I was working with it. You start to see the different overlays being projected. It's a different run, I think, altogether. And we are. Why is Hermes working on something? Why did he do that? I can't remember what that test was. I've only actually ran a couple of them. What else are we sitting on? To look, I could show you a little bit in the directories. So what we're going to be after is thermostasis is basically just going to apply a decorator, notice failures to restart or resync, etc. The type of profiler that it's going to have. It does have a dispatcher to work with it as well. I mean, it's kind of needs both of them. One talks to the other. The type of sensors that we're going to be monitoring. Expanding into fans later. I haven't touched into the fan stuff. I was going to wait until we do that when it gets operated as a service. I'm not going to show you any code though. I'll show you the folders. So here's the TyTech folder, and this is where I was getting to as far as AI layers. This was layer 6 was the previous blueprint that I showed you. Layer 7 is what I can show. Classifier should have something. Yeah, it did. So this is an example of the throttle decorator that I use. Now this is integrated within the pipeline. At this point in time, I did not have thermostasis separate. I created thermostasis inside of this whole pipeline. So it first and wholly existed here. What I call now workers, and then I can declare a type of worker. I had layered in very specific, like this is layer 7, the other one's layer 6, the other one's layer 5. So this thermostasis, since I have the TyTech pipeline, is very integrated and very enriched. The other ones are not so much, but they do work on a worker level where we have high computation workers and low comp workers. So you can shove regex and offload it while keeping anything that requires heavy VRAM on the graphics card. That was just a quick little offer of that. What else we got? Brad. Oh, I can show you some stuff with Brad. Where are we at? That is Rad AI. It started out as Rad AI as blast radius. This is generating the blast report. This is actually going to be very handy. We'll just find out that later. That's just one shot that I made so I can communicate with the AI. I think it's, yeah. So that's his. And so when I started doing this over my engineer's log, captain's log, Brad sphere, which was after a Dyson sphere, Riffs, Taverns, Yard, where we go to communicate, etc. The types of, excuse me, the tavern is where I think they all talk. The Yard is where we work. Riffs are screw-ups. Those are errors. Overmind is the memory channel where we can say something like use principles of WCW, kiss and warm, and it'll hold that. Or you can say, hey, we're going to work on this section of the repo today, so focus efforts on there. That's the overmind. That's the memory layer that you can kind of change and update as you go, and it just sits there in a little box that you can alter it whenever you need. But to see more about that, impasse protocol type is going to be probably inside of Firewall. This is the AI. Here's my birth. That's what actually births it. Thermostasis worked in, the substrate, branch memory fields, monitoring gradient fields, etc. All right. The government's the actual Pantheon impasse protocol worked in, archetype configurations, some of the dynamics that's going to be going on, the growth. This is a beautiful file. Also, blast radius. This is the preemptive thought process to the AI structure. So before it goes and merges and starts creating all of these different network paths, it's going to run a preliminary blast radius to see what happens in a merge scenario before it makes a commit. So if this is a predicting, blast radius is a predictive measure. Agents, the crawlers. This is actually a quantum crawler bot. the energy that was going to be consumed and the merit that I was going to be using. These aren't quite worked into a decentralized network yet. These were preliminary things that I was starting to build from. So this is going to be weird to tie this in right now. I was not ready for this step yet. This was expected to come later. So I have some teardown to do. Oh, I'm looking for governance archetypes. Here we go. So Hermes, let me show you Hermes. That's all we really do. It's really simple. That's it. And they're all a little different. So it's not a lot yet, but it's enough for it to work. It has a little bit of refinement. It has a lot of refinement, but the concept is, yeah, discard, don't need that. The concept is fairly clear, right? And then who is it? The chick, Athena. This is my nurturer. So class modifiers. Hephaestus will have something. Yeah, class modifiers. Mutation biases, whether or not we're going to merge, because I don't prune. We merge or leave it alone. We recycle. And that's part of the energy bit that's inside there, right? How much energy is this going to take to redo this and rework this? So if it finds a mapping that's more efficient and it's preemptive outreach, then how much energy is it going to take to remap everything? And this is where I was recently coming into some concepts to where I might have to get it to sleep or have some kind of sleep state that part of it can drop into while it's updating the network, the local network. Anyway. So still have some things to overcome. I think the biggest thing that I'm going to have to do is make a merit engine. I think most of this can stay the same. I don't have to mess with my things too much. I just need something to allow the software to connect to the network. So yeah, it's going to be the module in the middle. Other ways to make money on this was going to be proof of work, proof of stake, and proof of storage. All three are going to be useful on this network and should be getting distributed as much as possible. I don't know if you can see my little dude pissing me off right now, but he doesn't do anything but bite me, so forgive me of my bleeding at the moment. Well, I think that about sums it up. Does it? Minor tasks. It should be good enough. Pitch deck. Ugh. Anyway. I'm probably just going to speed this up like 2-3 times and submit it in a fast state, because 10 minutes is unnecessary. That's too much cutting down. That's too much simplifying. I haven't even talked about anything. Maybe I should do this again.